Hey there, everybody. Welcome to our bonus feature segment. First thing we're looking at are the GPS error spots. Yeah, the total electron content forecast, the coupled thermosphere, ionosphere, plasmasphere electrodynamics total electron content forecast. When your GPS has to communicate through a lot of free electrons, it can have massive errors. And we are seeing some chaos here, actually. Some sort of unexpected errors at nighttime. We'll let it play through one more time. So your GPS satellite's located at about 12,500 miles of altitude, and it's got to communicate through a lot of electrons. If it's trying to communicate with your GPS around the equator at noon especially, here's what we're talking about. Distances are shown here in miles, and your GPS satellite must communicate through the electrons in this plasmasphere, the Van Allen belt, this plasmasphere, and of course the rest of the atmosphere. So that's sort of why we show that. No charging hazards at the moment caused by any electrons or other high-speed particles. Here are the relativistic electrons over the past year reported by Solon.info. Here's a 3-day chart. And we should be coming up off of our lows here shortly following the subsiding of a coronal hole wind stream. I would expect this to be a little higher and this to be a little lower. So we're going to see some incorrect forecasts there by NOAA. And hey, it's a no harm, no foul situation, right? Next, looking at the ionosphere, the F layer is located about 300 kilometers of altitude. Here's the vibrational frequency going on above. It's showing megahertz here. And we definitely saw some low-frequency anomalies. Let's bring up the anomalygram. Here you can see a consistent low-frequency anomaly there right around the central Atlantic Ocean there, around the western coast of Africa and the central Atlantic Ocean there. Some wild swings. For those of you who are new viewers, you may not be aware that the South Atlantic anomaly is right about here. And it is the weakest spot in Earth's magnetosphere. You can clearly see a big demarcation line there, right around the central portion of the South American continent. That is the South Atlantic anomaly showing up all the time in the ionosphere. So big swings happening there. Some significant equatorial Atlantic Ocean low-frequency anomalies. Here's the latest image from 11:45 Universal Time on the ionogram. There it is on the anomalygram. By the way, if you enjoy the content, make sure you press like and subscribe. Tell your friends and foes about us. Let us know in the comments how you found the channel. The Smashers of Hazard appreciate it. Press that share button. Follow us on Twitter. We've got over 10,000 tweets. We didn't really start using it a lot until about 2019. And that's all you get to see. You'll have to head to twitter.com/smashamash to see the rest of what we've been retweeting. We've made some changes to the homepage at smashamash.com. Thanks to everybody who's checked that out. And welcome to the Neo-Renaissance. We're writing a publication to explain the solar polar field reversal and sunspot cycles. Once again, shout out to Eugene from Minsk, Belarus. We hope things are looking up. If you enjoy the content, please consider becoming a member of the Smash Team at smashamash.com/smashteam. We needed something more powerful than Patreon, so we built it ourselves. Also, feel free to check out the merch. You can find links below the video and on the homepage at smashamash.com to the Smasho merch. One of the featured products is Universum Liberate. If I could wave my magic wand, I'd set everybody free. Universum Liberate is the motto of the Galactic Federation Special Forces. So show your support for us, I mean for the Galactic Federation Special Forces, by picking up some gear. It's a sweet design, and it features this lightning bolt design, which is able to reach all the way across the galaxy instantly. The key is a reference to things like network and data security and integrity. And the galaxy is literally the galaxy, and this point of light is where we got the technology from. Universum Liberate, Galactic Federation Special Forces. And the next bonus feature is the ground-based solar observatory data from El Teide, Spain. El Teide, Spain, showing a ton of filaments here. It's not so tidy on the Earth-facing side of the sun. Huge filaments. This one looks like it's ready to coronally mass eject at any moment. More filaments down here. Filaments and filaments. Lots of filaments. It's time for an earthly CME, folks. We used to forecast them. We just stopped. You know why? Because if it don't make dollars, it don't make sense. Maybe we'll bring it back. Let us know in the comments what you think, as this is looking quite unstable from the El Teide Ground-Based Solar Observatory, which is, by the way, part of the National Sunspot Observatory. Next, we've got your intensitygram and colorized magnetogram. These are largely stable. 2956 has decayed to plage. 2957 has grown. I think this is actually a new sunspot, but I think that's just being known as 2957. 2958 is quite decayed there. It's still a beta class, I think. And 2959 is the most likely place to see major flares, so don't be surprised to see another M-class flare coming out of that region. It's quite magnetically complex. 2957 is quite magnetically complex as well. The rest of these groups are not likely to produce major flares, in my opinion. We'll close out with some more imagery here, like the GOES 16 SUVI. Keep an eye on this filament down here. And when I say ion, well, the pun is pardon the pun. Here's a close-up of this active region rising in the northeast. And we'll close out with a full disk view in the house favorite, 171 angstroms. Thanks for tuning in, folks. Congratulations on realizing the channel exists, and may that solar wind be at your back.